Hey everybody. In class today we talked about how to find solutions to a function when it's not in a simple y equals whatever kind of form. Tonight we're going to talk about how we take a function like that and we graph it, and then what that graph is going to look like. So let's start with example A here. We have 15x plus 5y equals 20. Remember, because y represents the output and x represents the input, it's a lot easier to work with this function if we can isolate the y variable, because that way we have the output equals an expression that involves the input, and we can just plug numbers into that. So what we're going to do here to isolate this y variable is we're going to use inverse operations. We're going to use the same process we use to solve any type of equation. The only difference is here we have another variable. So our first step is we have to get rid of this 15x over here, right? In order to get rid of 15x, I'm going to subtract 15x from both sides. 15x minus 15x is 0, right? That gives us 0. Since I'm doing that over there, I also have to do it over here. So on the left, I still have 5y equals. Now, a very common mistake I see is that people want to write 5x here. 20 minus 15x is 5x. But remember, these are not like terms, right? 20 and negative 15x are not like terms because 20 doesn't have an x next to it. So these two actually can't be combined. We can write this just as 20 minus 15x, because that's what this is, right? 20 minus 15x. We're just going to write that out right here. Now, our next step, we have 5 times y. We have to divide by 5, right? Just like if we were solving an equation for any variable, we would divide by 5. Divide by 5. Now, that gives us y equals. Now, we can separate this into two fractions because this is subtraction right here, because if this is subtraction or addition, we can actually separate it into two fractions, both with a denominator of 5. We can write this as 20 over 5 and minus 15x over 5. So that's going to give us y equals 4 minus 3x. So here is the function that we can use to create our table and then create a graph. Now, to create our table, right, we need x values and y values. Now, I can choose any x value I want. I always like to use 0 because 0 is always really easy to work with. Anything times 0 is 0. So if I put 0 in for x here, right, I'm going to have 4 minus 3 times 0. 3 times 0 is 0. So this really becomes 4 minus 0, which is 4. Okay? I can use 1. Negative 3 times 1, that's just going to be negative 3. So I still have 4 minus 3 is going to be 1. Right? I can put in 2. Negative 3 times 2, that's going to be negative 6. So 4 minus 6 is negative 2. 2, negative 2. Right? I can even throw a negative in there. I could do negative 1. Negative 3 times negative 1 is positive 3. So this function here would become y equals 4 plus 3. So I would get negative 1 and 7. So I have a table here. I don't need a ton of points, but I want to have enough points to give me a general idea of how this thing is going to look. So I'm going to scroll down here now so I can draw my coordinate plane. Now I know my highest y value that I calculated was 7. So I'm going to go up to 7. 1, 2, 3, 4, 5, 6, 7. Try to keep my spaces nice and even. And my lowest value from my table is negative 2 for my y value. So I'm going to go down 2. And then I'm going from negative 1. I'm going to put a couple more over there. And my x values go up to positive 2, so I'll put a few over here. And now I can plot my points. My first point, scroll back up a little bit, is 0, 0. Let's use a different color for this. Let's go yellow. 0, 4. It's going to be on the y-axis. X is 0. Y is 4. And then I have 1, 1. X is 1, Y is 1. 2, negative 2. So we go to the right 2, down 2. And then we have negative 1, 7. So we go left 1 and up 7 is going to be right about there. And I have my function. Now, I only chose 4 points, right? I only chose 4 points on purpose because I didn't want to have to do a ton more work, but I could have chosen any number of points. I could have done 3, I could have done negative 6, I could have done 0.2, and those also would have given me points on this graph here. So what I want to do is look at the pattern my graph is making, look at the shape, and continue that to show all of the different possible points. And we can do that by drawing a line. This is a straight line here that these points are in, and then we draw arrows to show how the line would continue. So by drawing this line, we're including all of the solutions that we graphed to begin with. We're also including all the solutions in between, all the solutions going down, and all of the solutions going up. All right, we're going to do 2 more quick examples where we solve for y, just so we get a little more practice putting these equations in the most useful form. So again, I'm going to draw my line through the equal sign right here, and I want to solve for y, the output variable. So to do that, to get rid of this negative 7x, I'm going to add 7x to both sides. Remember, I can't combine the terms on the right. I'm going to have 0 over here. I'm going to be left with negative 2y equals 6 plus 7x. Okay? Now I have negative 2 times y. I'm going to need to divide by negative 2. Divide everything by negative 2. So I have y equals, I can write this out as 6 over negative 2 plus 7x over negative 2. Now I want to simplify everything I can. Y equals 6 divided by negative 2 is negative 3. And I have plus 7 divided by negative 2. Now 7 divided by negative 2 could give me a decimal. I could also leave it as a fraction. Now remember, what I would do if I'm going to leave this as a fraction is I always want to write my negative sign on the numerator. So if I move that up there, I would have plus negative 7 over 2x. Now I can rewrite this one more time just to make it as simple as possible, because instead of adding a negative, I can just turn that to subtraction. Okay, so here we have our equation. In our second example here, example C, we'll start again by drawing the line. Now, y is over here. I'm going to leave y alone. I just want to solve for x. I can subtract 5x. Now, there are different ways to solve this problem, actually, to solve for y. This is one way. Eliminate the x term. We have negative y equals 4 minus 5x. And now, this is like having a negative 1 here, right? Negative 1y. So we will divide by negative 1. I will have y equals 4 over negative 1 minus 5x over negative 1. And when I simplify those, I will have y equals negative 4. Now here I have a negative 5x over negative 1, right? Because that's minus 5x. That's like negative 5. Negative divided by negative is going to give me a positive. Negative 5 divided by negative 1 is positive 5x. Now there's nothing else to simplify here, so this is my new equation. Okay? All of these lines that have this form, y equals mx plus b. Y equals mx plus b. M and b can be any numbers, are going to be called linear equations. Linear equations. We saw in our first example that when we graphed the points that we found, we had a straight line. That is going to happen anytime we have an equation that matches have this form here, y equals mx plus b, right? In this case, in example C, -4 is b because that's the number by itself, and the number in front of the x is 5. In example B, we have -3 is our b, -7/2 is our m, right? And we just have the x there next to the m. You can know that these are going to go in a straight line. You can remember that because the word line is right in the name. Okay? So anytime you can make an equation look like this, you know the graph of it is going to look like a straight line. All right, I know that was a lot. That's all for today. I will see you guys in class tomorrow. Have a good night.